This is Madison Wilkey,
and Todd Clark.
and this is our breathalyzer project for embedded systems.
It shouldn't be too high up.
So we're just going to go through really quick how it runs here. We have it running on a portable battery pack, so we don't have to have it hooked up to the laptop to run. We have an LCD screen, 1.44-inch LCD screen to give all our outputs. RGB LED. Then we're using a push button, a momentary push button to initialize the sequence. And then we have a switch on the side here. This sets either the maximum legal limit for blood alcohol content to be 0.08 or 0.05, depending on what state you're in. It lets you select that. So we'll do a test run here with no alcohol. So if we hit the button, it displays the results on our LCD, gives you the BAC, the maximum legal limit you've selected on the switch, and whether or not you are over or under the limit. If you're under the limit, the RGB lights up green and shows you that. And then if we switch the switch here, I'll push the button again and you'll see that update to 0.08 for the other mode. So to test it, we're just going to use some rubbing alcohol on a cotton ball. So we'll just put that near the sensor and that will pick up the alcohol. We'll push the button so it runs. And the closer we get with it and the longer it's there, the BAC will go up. So once it passes the legal limit, the lights will start flashing to simulate police lights. The board flashes and it gives you a warning not to drive and shows you your BAC. And then we have a ticker object that after 30 seconds it will reset it to its state, to the startup state, and you can do another test, or you can hit the button at any time to do another test whenever you want. And that's basically how it works.
Cool beans. Do we want to show some code?
Sure. Let's see. So we can go through some of our code here. So this is our PowerPoint for a presentation. Just going through each component. This is our LCD screen that we're using. And then this is just some sample code. So this code creates an object from a library that I found that was written by a guy we cited in the sources. But his stuff handles all the low-level serial communication with the LCD screen, makes it easier to write code for it, so you can just call that object for the code. And then this shows our ticker that's attached to reset our lights after 30 seconds of it not being used. Then we have the alcohol gas sensor that we're using for everything that has an analog output. That basically, it compares a ground level to voltage that's passed through the sensor and then to ground, and it compares the differences between the sensor, and that's how it gets the output. Then the code here shows that, so it gives you that the resistance as the input, and then to get voltage, this was gotten from the documentation on this particular part. So you times it by 3 to get your voltage. Then since it's a 5-volt output from the sensor and we only have a 3-volt input, we're timesing the voltage by 0.6 to get that 3 volts. And then the next one is a function that I created to give us the parts per million from voltage. And from that we calculate from parts per million of alcohol in the air to blood alcohol concentration. That's the rough formula. And then we calibrate the sensor to accommodate for variances in humidity and temperature. And then we return that result to be displayed. Then our momentary push button is what starts off the sequence. Here's some sample code on it. We're using it as an interrupt, and we have a debounce set on it at 200 milliseconds so that it doesn't rewrite itself. It won't go within 200 milliseconds of the last run. And it basically calls the function to run the test that goes through everything else on the other code. Then this is our I/O switch that handles our, we called it Utah mode because Utah is the state that has the lower BAC limit. And basically it just goes out to the switch on a digital in, return toggle switch. So if the switch is toggled true, then it returns true on a Boolean, and if it's false, it returns false. We then use that in the other code for our calculations. Then we have our 3.3 volt RGB LED. The code on that, we set up PWM out to 3 different pins, one for red, green, and blue, and then we have methods to change it to red, green, and blue to set the values on PWM for whatever color we want. And that's a sample of the code. We'll also include the full code in a repository on our PowerPoint presentation and a text file with the code as well, so you can look through that.
Okay, and then if you'll notice that this did reset, although it's been longer than 30 seconds. So yeah, good stuff.